Hi everyone. So now we'll discuss about the measurement of electropotential. Yesterday, however, I have discussed about the how to measure electropotential, and very clearly yesterday I have explained that the electrode potential of an individual electrode cannot be measured. The electropotential of a single electrode cannot be measured. To measure electrode potential of an electrode, we should use a reference standard. For our syllabus, the reference standard is given as the standard hydrogen electrode is our reference standard. So however, yesterday we have discussed about the construction and the chemical reaction and the cell representation of standard hydrogen electrode. So now we'll continue the measurement of electrode potential. How the electrode potential of all other electrodes can be measured with respect to standard hydrogen electrode as a reference standard or reference electrode. So now today we'll discuss about the measurement of electrode potential of copper electrode. The first we'll measure the electrode potential of copper electrode. So here, to measure electrode potential of copper electrode, what we have to do? Just we have to take copper electrode and our reference electrode. Reference electrode is none other than our hydrogen electrode. So as already I said, our reference electrode, for convenience, our reference electrode is taken at left side, means at anodic electrode. Here see the diagram. This setup indicates the measurement of electrode potential of copper electrode. So in this representation, I have taken standard hydrogen electrode at my left side. Left side means anodic side. At anode, the hydrogen electrode is kept. At cathode, I have taken my copper electrode. The electrode whose potential to be measured should be taken at right side. It is taken as cathodic electrode. Now this is anodic electrode. The standard hydrogen electrode is our anodic electrode. To measure electrode potential of any electrode, we must take hydrogen electrode on left side and the other electrode on the right side, means cathodic part. So now we'll represent this combination of two half cells. So this is standard hydrogen electrode is a half cell and the copper electrode is another half cell. The combination of these two half cells make a cell. So we should represent a cell. So here, to represent a cell, yesterday we have discussed about how to represent a cell. So here, this is cell representation of this cell. Here, first I have taken anodic part. At anode, the oxidized part is written first, then reduced part. But first I have taken hydrogen electrode, then I have taken copper electrode. This is our standard hydrogen electrode and this is our copper electrode. And we know how to represent. Here, for the standard hydrogen electrode, the half cell representation is yesterday only given. The half cell representation is here the platinum and hydrogen gas at 1 bar pressure and H plus ions in the aqueous form. So this is the cell representation of standard hydrogen electrode. Platinum, hydrogen gas at 1 bar pressure. Here we have to blow the hydrogen gas constantly at 1 bar pressure. 1 bar is nothing but 1 atmospheric pressure. Here the solution taken is 1 m H plus ion. The solution must contain the electrolyte present in the standard hydrogen electrode or normal hydrogen electrode must contain 1 molar concentration of H plus ions. See here, H plus ion, the aqueous solution of H plus, their concentration is 1 molar concentration. Now these two are separated by, these two electrodes are separated by salt bridge. So these two are separated by salt bridge. Separated in the sense what? Internally connected. And next, the right side electrode. Which is our right side electrode? Copper electrode is our right hand side electrode. See here, copper. Here the copper rod is dipped in the copper sulfate solution which contains 1 molar concentration of Cu2 plus ions. Here the concentration of Cu2 plus ions is 1 molar. 1 molar concentration of Cu2 plus ions. And it is This in this solution the copper rod is dipped, it indicates copper electrode. This indicates our standard hydrogen electrode. So by making a setup like this, we can measure the standard electrode potential of any electrode. And experimentally we know that experimentally by performing the experiment we got some value for this reaction. The EMF of the cell, EMF or the cell potential of the cell is found to be 0.34 volt. The overall cell potential of this entire cell is found to be how much? 0.34 volt. It is a experimental data. So now by using this data we have to calculate the electrode potential of copper electrode. So what is the formula to calculate the EMF of the cell? Do you remember? Yes, it is E naught cell is equals to E naught right minus E naught left. So till now we have discussed about only E cell is equals to ER minus EL. ER means E right minus E left. Here I have written naught. These naught are degrees. This degrees indicates the standard. And yesterday I have cleared one more point. Any electrode, the electrode potential of any electrode measured with respect to hydrogen electrode, standard hydrogen electrode is taken as standard electrode potential. So because of that reason I have taken EMF of the cell or standard electrode potential of the cell is equals to standard electrode potential of right side electrode minus standard electrode potential of left side electrode. And we know that this value E naught cell is equal to how much? 0.34. It is experimental data. 0.34 volt. E naught or minus. What is E naught L? E naught L. Sorry. To be more clear, I will write clearly. E naught right on the right side. What we have taken? We have taken E naught of Cu2 plus bar Cu minus. On this side we have taken which electrode? Hydrogen electrode. We have taken hydrogen electrode, the standard hydrogen electrode. So we will take H plus bar 1 by 2 H2. 1 by 2 H2. On the left hand side we have taken this electrode, on the right hand side we have taken this electrode. And we know that the standard electrode potential of standard hydrogen electrode is always 0. At all temperatures the standard electrode potential of hydrogen is 0. And 0.34 volt is equals to is equals to E naught Cu2 plus bar Cu. So minus 0. Therefore the standard electrode potential of Cu2 plus bar Cu is equals to 0.34 volt. And we found that the standard electrode potential of copper electrode is found to be 0.34 volt. So from the experimental data we calculated that the standard electrode potential of copper is 0.34 volt. So I will write this. The standard electrode potential of copper electrode is equals to 0.34 volt. So electrode potential is always measured in terms of volts. Here the electrode potential means what? This electrode potential is nothing but the standard reduction potential of copper electrode. So in this experiment the copper is reduced. Copper is reduced according to the formula. How it is reduced? Cu2 plus 2 electrons gives Cu. The copper is reduced, so the copper is taken as cathode and our hydrogen electrode behave as anode. So this is the electrode, the standard electrode potential of copper electrode. So the standard electrode potential of copper electrode can be calculated like this. Okay. So now we will calculate the standard electrode potential of one more electrode, that is zinc electrode. So now we will calculate the standard electrode potential of zinc electrode, the standard reduction potential of zinc electrode. So now how we have to calculate the standard reduction potential of zinc electrode? So what are the necessary changes we should make here? Here we'll write the cathode and anode at last. So here this is our zinc now. Now I have taken zinc electrode. Here the electrolyte must be Zn-SO4. It must contain Zn2 plus ions. Now our electrolyte should contain Zn2 plus ions. So now we'll calculate the standard electrode potential of zinc electrode. Now how to represent this cell? So as already I said, the standard hydrogen electrode is always taken on the left side, and the electrode whose electrode potential to be measured should be taken on the right side. Here now I want to measure electrode potential of zinc electrode. So how the cell is represented now? This is our half cell representation of standard hydrogen electrode. Now we'll represent the continued part of this will be zinc electrode. Zn2 plus in the aqueous solution. Here its concentration is 1 molar concentration and Zn. Okay, so now this indicates, so this is our zinc electrode. Zinc electrode. This is the cell representation of the given cell. This is the cell representation of the given cell. So now we'll calculate the E0 cell or standard cell potential of the cell. By this experimental setup, we found that the electrode potential of this cell is found to be minus 0.76 volt. It is found to be minus 0.76 volt. So now by using this data, we have to calculate the standard reduction potential of zinc electrode. So here, what is the formula to calculate cell potential? And once again we have to write EMF of the cell is equals to E0 cell is equals to E0 right minus E0 left. On the right hand side, which electrode we have taken? We have taken Zn2 plus bar Zn minus. On the left hand side we have taken E0 H plus 1 by 2 H2. So here E0 Zn2 plus bar Zn, E cell is how much? Minus 0.76 volt minus 0.76 volt minus 0.76 volt is equals to E0 Zn2 plus bar Zn minus. So what is the value of the electrode potential of hydrogen electrode? It is 0. 0. So therefore E0 Zn2 plus bar Zn is equals to minus 0.76 volt. See here? So this is the standard reduction potential of our zinc electrode. The standard reduction potential of our zinc electrode. First we have calculated standard electrode potential of copper electrode, and now we have calculated standard reduction potential of zinc electrode. With respect to what? By taking the standard hydrogen electrode as a reference electrode, means we have calculated electrode potential of copper electrode potential of zinc electrode with respect to hydrogen electrode, the standard hydrogen electrode. And I'll write the E0, the standard electrode potential of Zn2 plus bar Zn is equals to how much it is? Minus 0.76 volt. Minus 0.76 volt. So like this, the electrode potential of any electrode can be calculated like this. And now we'll calculate the electrode potential of Daniell cell or the cell potential of Daniell cell. So by taking the data, we have to calculate the cell potential of Daniell cell. Daniell cell. So how Daniell cell is prepared? Here for Daniell cell we have to remove this hydrogen electrode. This hydrogen electrode is replaced by which electrode? Zinc electrode. Here we have to take zinc electrode on the left hand side. I will take zinc electrode on the left hand side and copper electrode on the right hand side. So this is the experimental setup made for the Daniell cell. This is our ZnSO4 solution whose concentration is 1 molar concentration. This is our zinc. This behave as anode and this behave as cathode. And here this is copper. Here the solution is, or electrolyte is copper sulfate solution which contains Cu2 plus ions. So this is the experimental setup for which Daniell cell. So now let us once again write cell representation of Daniell cell. How to represent Daniell cell? And yesterday we have represented Daniell cell very clearly. Once again I will write Zn is dipped in Zn2 plus aqueous solution whose concentration is 1 molar concentration, and this is internally connected with or separated by the salt bridge, and Cu2 plus aqueous solution whose concentration is 1 molar concentration, and in this solution copper rod is dipped, means it indicates copper electrode, this indicates zinc electrode. So now we have to calculate the cell potential of this cell. The cell potential or EMF of this cell can be calculated. So what is the formula? The very same formula we have to use. E naught cell is equals to E naught right minus E naught left. On the right hand side, which electrode we have taken? On the right hand side. On my right hand side I have taken copper electrode. Here the standard electrode potential of copper electrode Cu2 plus bar Cu minus the standard electrode potential of zinc electrode Zn2 plus bar Zn, and we know the values of standard reduction potential of copper electrode as well as the standard reduction potential of zinc electrode. So here the standard electrode potential of copper electrode is found to be 0.34 volt minus the standard electrode potential of zinc electrode is minus 0.76 volt. 0.76 volt. So now 0.34 volt minus into minus plus 0.76 volt. How much it is? On adding 0.34 volt, 0.76 volt. 0.34, 0.76. So it is found to be 1.10 volt. So the E naught cell of Daniell cell is found to be 1.10 volt. So in the previous session we have discussed about E naught cell of Daniell cell. So you might be remembered that the E naught cell of Daniell cell is the EMF of this cell of the Daniell cell is 1.10 volt. On adding external current, this reaction stops and this changes, isn't it? So E naught cell is equals to 1.10 volt, means the cell potential of Daniell cell is equals to 1.10 volt. So like this, the electrode potential of any electrode can be calculated by referring with respect to standard hydrogen electrode. We have to take standard hydrogen electrode on the left hand side and our another electrode whose cell potential to be measured should be taken on the right hand side or at the cathodic part. So by taking like this, we have to calculate the cell potential or electrode potential of any electrode. So I hope all of you understood this. Thank you so much for watching.